Hello, and welcome to a brief look at SDN, or Software Defined Networks. This will be a very high-level overview of SDN and is intended to provide the viewer with some basic knowledge of the concept. SDN is a very interesting and potentially revolutionary concept. At a very basic level, SDN is a group of technologies developed to make modern networks more agile and scalable. But what does that really mean? Let's take a look at a more specific example of the agility a software-defined network can provide. First, we're going to look at why it is important. Then, who developed SDN? Next, how does it work? And lastly, how will it impact the future? So why is SDN so important? Let's take a look. SDN makes networks more modern and more scalable. Currently, most networks implement traffic shaping and QoS to ensure that desired traffic is prioritized over the less important traffic. For example, generally, you would want VoIP RTP packets to be prioritized over FTP packets that are for file sharing. Since the VoIP call is considered real-time service, it is generally prioritized first. But what if in certain circumstances you would want to change these prioritizations quickly or even instantly? Currently, it's not practical to try to do this, and as most network devices responsible for implementing QoS are distributed or they are not centrally managed. These would include routers, switches, and firewalls. A change at this level would require a network admin to log in to the devices and make a configuration change in hundreds of devices. While there are some basic GUIs for doing this, they are not a robust solution. Now conversely, SDN has the potential to allow these network devices to dynamically change their QoS settings in response to a programmed event, like high link utilization or at the flick of a switch by an administrator. The configuration changes can be implemented across hundreds or thousands of devices at once. Next, let's look at who developed SDN. The origins of SDN are somewhat shrouded in mystery, partially because SDN is more of a general concept than a specific technology, similar to how virtualization is a somewhat broad concept rather than a specific solution. What is generally accepted about the creation, or at least the recent rise in popularity, was the work of Martin Casado. While spending time at Stanford, while there, Martin and several others developed something called OpenFlow. OpenFlow was a very unique concept of allowing the data plane and the control plane to be separated and decentralized. Next, we'll look at how it works. As we briefly mentioned, SDN separates or decouples the control plane from the data plane. In a classic router or switch, the fast packet forwarding or data path and the high-level routing decisions called the control plane occur on the same device, the same hardware. With an OpenFlow switch, these two functions are separated. The data path portion still resides on the switch, while the high-level routing decisions are moved to a separate controller, generally a standardized server. The OpenFlow switch and controller communicate via the OpenFlow protocol, which defines messages such as packets received, sent packet, modify forwarding tables, and get statuses. Next, let's look at how we think SDN will impact the future. SDN will continue the trend in centralization of computing resources, as we have seen the last several years following the virtualization boom. SDN also allows for high bandwidth video, and some engineers even fear the future of SDN, as it may put them out of work, as SDN simplifies and streamlines configuration of network equipment. Thank you for joining me for this brief overview of SDN. Let's recap what we looked at. We looked at why SDN was important. We looked at who developed it. We looked at how it works. And we looked at a few things how it will impact the future. I want to leave you with a quote from Martin. You want networks to be as flexible and as agile as compute is. That's not the case today, but that's where we're going. Again, thanks for joining. See you later.